This is task 2, 9.5, task 2. All right, what we're going to do here is we're going to practice graphing inequalities. Okay, when we graph inequalities, we have to take into account something that's called a constraint. Okay, constraint is a condition that restricts the values of a quantity, and that might sound confusing. So I'm going to explain it here, okay? So when we have an inequality, sometimes we have an inequality that looks like this, right? Y is less than or greater to, or less than or equal to -3. When we have less than or equal to, that means it can be less than or it can be equal to. Okay, so we're going to use a solid circle at -3 to show that -3 is a solution. Okay, there's two different ways that we can write this. Is when we graph this at -3, we're going to color in a solid dot. And then we are going to shade the number line to the left of -3 to show that numbers less than -3 are also solutions. So y can be anything that is -3 or less. So we're just going to kind of like shade it so it kind of looks obvious like that. We're going to draw an arrow, which means y is anything -3 or less, okay? Or I guess my camera's backwards. It would be like this, -3 or less, okay? Okay. When the sign is or equal to, right? Greater than or equal to, less than or equal to, you do a solid circle, okay? Now, sometimes we have to check our solution. So this step 3 here, right? Check your solution, think in your mind. If y is less than or equal to -3, think of a number that's less than -3. Would it be included on that side of the number line? Okay. You can substitute anything in for y that would be less than -3. Okay, I choose -15. Well, -15 would be somewhere way down here, which would make it true, right? That is the shaded side of the number line. Okay. All right, we're going to graph 1 is less than m. Okay. So unlike this one, which says it can be less than or equal to, this one says it can't be equal to, it can only be less than, because that little equal sign line is not there. Okay. So when we shade in this line, we're going to use an open circle at number 1 to show that 1 is not included. Okay, m cannot be 1. It can only be less than 1. Okay, or I'm sorry, 1 is less than m. So m can only be something that's more than 1. Okay, so you are going to shade the number line to the right of 1 to show that numbers greater than 1 are solutions. So that means that we're going to shade in, we're going to start at our open circle, and we're going to shade in the number line. Draw an arrow like that. Okay. And this is how you write something that is not included, right? 1 is not included. 1 cannot be the solution. Only things greater than 1 can be the solution. Okay. So let's check our solution. Pick any number for m that falls on the shaded section of the number line. So you can choose your own number. I'm going to choose 5. Well, 1 is less than 5, which makes it true. Okay. All right. So the way that I remember this is because sometimes it might be hard to remember when to use this and when to use this. Okay. I always think that if, say, you were invited to a party, you've been invited to the party, you are -3. You have been invited to the party. That means that you are shaded in. You're just like the rest of the line. You're nice and shaded in with everybody else. Okay? And so you're going to be just like the rest of the line because you have been invited. You are going to be there at the party. Okay? You're included. But say all your friends decide to be mean to you and not invite you to the party, okay? Then you would be like 1 in part B. Okay? You'd be like 1 in part B. Because you would not get an invitation, you'd be left out in the cold, all empty. So that means you are not included. You have not been invited. Sad. So that's how I remember it.